Hello all, let's start part 2 of section 3.2, right? Part 2 of my lecture. Section 3.2, still we are in 3.2. And this part of the video, or in this part of the lecture, we are discussing the zeros of a polynomial function. What is the definition, or how to explain what is the zero or zeros of a function? If we have a function f, correct? It's a polynomial function f. The values of x, it means it's variable in the function, which changes the f of x equal to 0, correct? Which changes the f of x equal to 0. We call those values the zeros of polynomial function f, correct? For example, if I translate it in a numeric example for you, if I have f of x equals x squared plus 9x, a very simple one, plus 20. There are some values of x that changes this polynomial to 0, or changes the f of x to 0, correct? Those values, we call it the zeros of polynomial function. In the second way of explanation, the zeros of a polynomial function is actually the solution of that equation, the solution of that function equation. If you change, instead of function, make this one as an equation, the zeros of your function is actually the solution of your equation. You see here I have f of x equals x squared plus 9x. If I write x squared plus 9x plus 20 equals 0, it's an equation, right? The solution set for this equation is actually the zeros of your polynomial function. When I'm explaining it this way, that the solution of your equation is the zeros of your polynomial function, it gives you a lot. Actually, it gives you a method how to find the zeros of a polynomial function. How to find the zeros of a polynomial function. In one hand, in one way, I explain the values that changes the f of x equal to 0. In the other hand, I explain that it's the solution of this equation, correct? Then this is the method. If someone asks you to find the zeros of a polynomial function, what you do, immediately set your function equal to 0. Or replace the f of x with what? With 0. Then, some of polynomial functions, they can be factored. Some of them you cannot factor. There is another method that later I will teach you to how to find the zeros of a polynomial function. But at least in this section, we are covering the polynomial functions that you can factor and you can find the zeros of that polynomial function. Now, if I factor x squared plus 9x plus 20, of course here x and x, I'm looking to two numbers. To multiply gives me 20, to add gives me 9. Of course 4 and what? 4 and 5, both of them positive. Now set each parenthesis equal to 0. X plus 4 equals 0. It means x equal negative 4, right? And x plus 5 equal to 0. From here, x equals negative 5. We call x equal negative 5 and x equal negative 4, the zeros of polynomial function. Or if you write it as a point, correct? One of the zeros is at negative 4 and 0. The other zero is negative 5 and 0. Now, the zero of a polynomial function means the x-intercept of your function. It's the same as finding the x-intercept or intercepts of a polynomial function. You see, we are just changing the name, but the method is actually, you know it from long time ago, how to find the x-intercept or intercepts of a polynomial function, correct? We name it here what? The zeros. Let me do another example. Then I will not show you here any graph. I don't want to show you the graphs yet because later in section 3.3 or 3.4, we will do a lot of graphing, right? We will graph different polynomial functions, the complicated ones, not the easy ones like this, the higher degrees. We will graph those. I'll teach you how to graph those even with your hand. No need for calculator, correct? Let me do one more example for this part. Example number 2, and I'll copy maybe this one from your book. Find the zeros of polynomial function. The function is given as a f of x equals x cubed plus 3x squared minus x minus 3. Right now, if I ask you to find the zeros of this polynomial function, the only method that you know is factoring. How to factor a polynomial function which has 4 terms in it? You see, I have 4 terms. Definitely, I will use grouping. Because usually with 4 terms, what we do, we use grouping to factor. Correct? Now, f of x equals, what is common between x cubed and 3x squared? Of course, x squared. Correct? What left here? Left x plus what? 3. What is common between negative x and negative 3? Between negative x and negative 3, the only common factor is negative 1. Correct? Then parentheses, x, negative times negative divided by negative gives you positive 3. Now, f of x equals, from the parentheses that they are the same, we copy one of them, right? X plus 3. And we put the other two, which is x squared minus 1, in the second parentheses. X squared minus what? 1. And I can say f of x equals x plus 3. If I am a good student, if I look to the second parentheses, immediately I know, oh, I can factor it again. This is the difference of the squares, right? My second parentheses, this is the difference of the squares. Then I'll open 2 new parentheses, x minus 1 and x plus 1. Now, to find the zeros, I'll set all these parentheses equal to 0. I'll put x plus 3 times x minus 1 times x plus 1 equal to what? 0. From here, x plus 3 equal to 0, it means x equal negative 3. X minus 1 equal to 0, it means x equal 1. And x plus 1 equal to 0, it means x equals negative 1. This polynomial function has actually 3 zeros or 3 x-intercepts. The first one, negative 3 and 0. The second one, negative 1 and 0. And also 1 and 0. These are the zeros of this polynomial function or the x-intercept of your polynomial function. I will do one more example. Correct? I will do one more example. Then I will discuss another important topic, which is directly connected to the zeros of a polynomial function. Correct? Let's do, before that, one more example for this. I don't know which number is that. I'll put just example number 3. I think I did 3 examples for you. F of x equals f of x equals negative x to the power of 4 plus 4x cubed minus 4x squared. They are asking you find all zeros of this polynomial function. As we discussed, to find the zeros of this polynomial function, what I do, I'll set this polynomial function equal to 0. Negative 4x to the power of 4 plus 4x cubed minus 4x equal to what? To 0. To make my life easy, because I have equal to 0, I will multiply all the terms, or I will multiply my equation by negative 1, correct? Which gives me x to the power of 4 minus 4x cubed plus 4x equals negative 1 times 0, again gives you what? 0. Now, can we factor? Of course, GCF factoring, correct? You see x is common between all of them. Then x, what left here? X cubed. That's a 4x squared, not 4x. Then x squared is common, correct? What left? X to the power of 4 divided by x squared gives you x squared. Minus 4x cubed divided by x squared gives you 4x. Plus 4x divided by 4x squared. Divide by x squared gives you what? 4. Equal to what? 0. Now, can I factor the inside? You see the factor of the inside is x minus 2, right? I see it so fast. X squared, because it gives you x minus 2 times x minus 2, I can write it as x minus 2 squared equal to 0, because I have two factors the same, x minus 2 and x minus 2. Now, from here, x squared equals 0, it means x is equal 0. X minus 2 squared equals 0. Correct? Which you can say from here, x is equal what? Equal to 2. Now, these are the zeros of your polynomial function, which is 0, 0. It means this function is passing somehow from the origin of coordinate system, and the other 0 is 2 and 0, which is another x-intercept or x-intercept of your function. The next topic, which is important, and maybe this is one of the questions of your second test, definitely one of these comes in your test. Let me give you a hint. Multiplicities of 0. Multiplicities of zeros. What does it mean? What is the multiplicity of a zero? In different examples that I did, I found zeros of a polynomial function, and some of them you had different factors, and some of them, like the last one that I did for you, your two factors were the same. Like you had this one, x squared times x minus 2 squared. You see here, x minus 2 squared means two factors are the same, x minus 2 and x minus 2, correct? Or x squared, it means x times x. Two factor is the same, correct? Now, what is happening to the graph if two factors is the same, or if you have only one factor? What is the difference? What is the difference between this example or maybe this example? X minus 2 times x plus 3 times x minus 1. What is the difference between this example and this example? Let me first explain. In this example, if you set this one equal to 0, and if you look to your coordinate system, x and y, correct? These factors are showing the x-intercept of your graph, or it means these factors, which gives you one of them is 2 here, the other one is -3 here, and the other one is 1 here. It means the graph of your function, somehow, I don't know how, what is the shape? The graph of your function is passing the x-axis or crossing the x-axis. If you have an odd, we call it odd multiplicity. If you have an odd, remember, let me write here, odd multiplicity, when you have odd multiplicity, the graph crosses or intersects the x-axis. When you have even multiplicity, the graph touches the x-axis and turns back. Like this example, like this one, x minus 2 squared. If you see the graph of this, x minus 2 squared, it means I already found the zeros of this polynomial function for you. The zeros of this polynomial function was x equal 2. It means at x equal 2, the graph comes, touches the x-axis, and goes back from where it comes. Maybe from down or maybe from, but just touches. Then remember, if I ask you find the multiplicities of zeros of a polynomial function, you evaluate this way. If you factor and you see even multiplicity, the graph touches. And if you find odd multiplicity, the graph crosses the x-axis. Correct? I'll stop the video here. And the next one, we will talk about how to graph a polynomial function.